So what we're going to work on today, in addition to using them to find the 10th or the 11th or whatever term, is you're going to now take the information and write me the explicit or the recursive rule for the sequence. So you have your two rules. You do not have to memorize these. These will always be given to you. I've got them on the board over there, so they're always just real handy to look at. They're also on the formula sheet for the end of course test. You just have to not be lazy, and you just have to click it and look it up. Now, in order to write either of these two, in order to use a geometric sequence, you absolutely must know two things. You must know the very first term in the sequence, which is referred to as a sub 1. That is the first term. You also must know what you are multiplying by, and we call that the constant ratio. That is what you are constantly, over and over, multiplying by. Now, sometimes you'll get lucky and the problem will say you have a first term of 7 and a constant ratio of 3. If that's the case, you got it. Other times, I'll give you an actual sequence of numbers. You can find the first term. Where are you always going to find the first term in a sequence of numbers? You're not being a smarty pants. The first term is the first number. But your constant ratio, you might see it immediately, those of you that are really good with just like quick math facts, or you might not. You may have to calculate it. You're going to take a sequence value and you will divide by the previous term. So we refer to this as y2 divided by y1 because y1 would come first. So if I pick 216, 72 came before that. If I pick 24, what would I have to divide by? What came before that? 8. That's how I would find my constant ratio. So every time you get ready to write this rule or use these rules, you need to be able to find those two things. Example 1 says, write the explicit formula and the recursive formula for the following geometric sequence. So your sequence is 8, 24, 72, 216, and 648. I told you no matter what you're doing, you need two things. What two things do you need to know? First term, constant ratio. So I'm going to come make myself a note. I got to know A1 and I got to know R, the first term and the constant ratio. Now, I'm not being a smarty pants. You're not being a smarty pants. But if somebody says, how do I find the first term? Where are you going to find the first term? The literal first number. So first number is 8. That's my first term. That's why it's called the first term. Now, some of you are really good at looking at the numbers and seeing the patterns. And that's great. Anybody know right off the top of their head without doing any division what you're multiplying by? 3. Multiplying by 3. That's great. If you see it, great. Some of you, and sometimes the numbers will be harder. Some of you are more like me. I know my multiplication facts, but my brain just doesn't process them like with a crazy speed. So I will pick an R or pick a Y value, a sequence, and I'll divide by the previous like it said. So we were talking about that just a second ago. So if I pick 216, what is the previous term in the sequence, the one that came before it? Would be 72. So divide by 72, you were right, it's 3. Now, in order for this to be a true geometric sequence, we would have to make sure that every one was multiplying by 3. All right, what if your friend picked 72? If they pick 72, what is their previous term? 24. So 3. Now, it's really similar to when we did this with exponentials with a table. If you are struggling with too many options, if you say, I don't know what to divide by, I tell students that are struggling a little bit, pick the last term. Pick the last one they listed, 648. Because what's the only option for a previous term if you pick the last one? 216. The only one you can't pick is the first one. Why can't you pick 8?
Because there's none in front of it.
Very good. There's nothing before it. Okay? So, 648 divided by 216 is, just like everything else, a constant ratio of 3. So now I know I start with 8. I know that I multiply by 3. So if I wanted you, like in elementary school when they said find the next 3 terms, what would you do to find the next term? Multiply by 3 and get that number. Multiply that by 3 and multiply that by 3. Okay? That's recursive when you just continue the pattern. Now, they didn't ask me that. They said give me the explicit formula or the explicit rule. Give me the recursive rule. So I'm going to give you the explicit rule, or you're going to help me get the explicit rule, and then we're going to get the recursive rule. This is a formula. In a formula, there's numbers that you don't know, but guess what? You just found out some stuff. Take what you used to not know and plug it in. You used to not know A1, but now you know A1 is 8, so you'll put it right there. You used to not know R, but now you know R is 3, so you put it right there. You still don't know N, but that's because you're writing a rule. So, A sub N, I don't know N, equals A1, which is 8, times R, which is 3, to the N minus 1. That's my rule. That's all I got to do to write the rule. Now, I wrote it with a dot. But you know, I've told you before, I don't usually use the dot because Miss Slusher gets writing fast and it looks sloppy and my dot might look like a decimal. What is another way I could write this and still be the same? With the parentheses. So A sub N equals 8 parentheses 3 to the N minus 1. Which one's right? Both. You're going to see it written both ways. If I type it, I might use the dot because you can obviously tell when I type it, it looks different. If I write it, I usually personally write it with the parentheses. This is my explicit rule. Both of them are right. It is just a different notation of how to write it. All right, so let's write the recursive rule. You look at the recursive formula. You plug in anything you know. I don't know N, so I start with A sub N equals. Do we now know R? What's R? 3. It's what we multiply by. And then parentheses A sub N minus 1. That's the rule. So if I ask you to write the rule, that's what I'm looking for. Now, if I asked you, if all I gave you was this, the rule, the only thing you can tell me is I'm multiplying by 3. But if I don't tell you where to start, you can't actually carry out the rule. So a lot of times, now I put a box around the rule. We'd have to follow that up with a side note, kind of like with an A1 equal to 8. Why would I need to know A1 equals 8? Because what A1 tell me? The first term tells me where to start. The rule is this. This is the heads up of where you'd have to start, okay? So if you're looking at a test, you're only going to see the actual equation, not this little afterthought. Now, there's one thing I forgot to, we've mentioned it before, but I want to mention it again. I want to remind you. What's that A sub N minus 1 represent? That's your previous term. So if I give you this recursive, this means take your previous term and multiply by that by 3 to get to the next one, okay? All right. Example 2 says, write the explicit formula and the recursive formula for the following geometric sequence. So, here's my formulas. What do I need to write and use both of my formulas? I have to know 2 things. What are those 2 things? First term and constant ratio, what I'm multiplying by. So, if you had to tell somebody who was absent or confused where they're going to find the first term, where do you find the first term? It's the very first number. When you start the sequence, you read left to right, your very first term is 3. Now, some of you might even be able to look at that and tell me what I'm multiplying by. All I know is these numbers are getting smaller, so I know I'm multiplying by some sort of number like between 0 and 1. Yes, Frank?
This whole paper, should it all be like the same?
The same process? Yeah. Different numbers.
Yeah.
Oh, across here? Yes, they have to multiply by the same thing, whatever that is. So we could each pick 2 different ones to find our R, and we should still be right. Now, let's find our R. You can pick a term and divide by the previous, okay? So I have often said, if you struggle with this, this can get really confusing, but it doesn't have to. Pick the last term. The last term is 0.375. What is the only option for the previous term? 0.75. Okay? Now, type that in your calculator. So if I've got 0.375 divided by 0.75, it is 0.5. Now, technically, what is 0.5 as a fraction? 1/2, okay? You could use the decimal or the fraction. But since the sequence used the decimal, what would it look better to keep using? The decimal. Kind of keep it in the same, like the same look, okay? Now, you say, Miss Lusher, I did not pick 0.375. I picked 1.5. That's fine. If you're at 1.5, what is the previous term that you should divide by? You back up and you go 3, which is 0.5. If you pick 0.75, what do you have to divide by? Previous term of 1.5. No matter which one we pick, we divide by the previous, we're going to get 0.5. So now, let me grab my Post-it note with my formula so I don't have to keep moving this up and down and making you car sick looking. I want you to help me write my explicit formula. I will go ahead and tell you, if I use a decimal, I put it in parentheses, okay? Because that's all I need is to think I got 2 decimals in a number. A sub n. You're writing the rule. You don't know n. So A sub n equals. Do you know what A sub 1 equals? 3. Times, do you know what you're multiplying by every time? Your R. 0.5 to the n minus 1. You take whatever you know and just plug it in. This is your explicit function rule. All right, let's write our recursive. So if I want the recursive sequence, I'm going to look at the recursive formula right here, and it says A sub n. I don't know A sub n. That's because I'm writing a function rule that would work for any n, any number. Equals R. What is our R? Our R, what we're multiplying by is 0.5 times A subscript n minus 1. This is my function rule. But if I wanted you to use that rule to write the sequence, what else would I have to tell you? I'd have to be like, oh yeah, BT dubs, A1 is 3. Okay? The only reason I write that is because if you want to use it, you got to know where to start. All right, I'm going to change up number 3 just a smidge. Okay? I want you to just mark through write the corresponding exponential function. That's just not going to help you. It actually confused my other class, so I don't want to do it with you. And I want you to change that to write an explicit formula for the sequence and the recursive sequence formula or rule. Okay? So I want you on this problem to do the same thing we had to do here, except you don't have to figure out the R. I gave you A1 and R. So you need to identify what is A1 and R, and then I want you to write the explicit rule, and I want you to write the recursive rule on your own, and then in just a second we'll check them. All right, let's see how you did. According to this information, what is A1 going to be? 7. How'd you know? It says first term is 7. That's right. All right. What is your R? What's that represent? 4. That's the constant ratio. That's what you're multiplying by over and over and over. All right, so let's write the explicit. You don't know n because you're writing a rule. A sub n equals A1 is 7 times 4 to the n minus 1. Now, Ms. Slusher is probably going to write her answer like this. If you're comparing answers with another student and their answer looks like this, are they good? Yes. Now, don't write this down. What is wrong with this? It's backwards. This is telling you that you start with 4 and you multiply by 7, and that's just simply not what you said you were going to do. Okay? So yes, it matters. You say, Miss Slusher, if this was a multiple choice test, would you have put that as an answer choice? I sure would have. Okay? So you need to make sure when you take any of these tests, you got to stop getting in a hurry. You want to take your time. Recursively, I'm looking at this rule. A sub n equals my r. What am I multiplying by over and over? 4 times a sub n minus 1. Because I multiply by 4 over and over. And then, if you wanted me to use this, you would have to say, with an a1 equal to 7. What we're going to do a lot on the back is we're going to use those two functions. You can work most of these problems recursively or explicitly. And that is going to depend on you and what you like better. Some of you would rather continue the pattern. That's totally fine. You're going to get to the right answer. Some of you say, I would rather write a function and plug in one number and go straight to the answer. That's explicit. That's fine. What I'm going to do on our notes is I'm going to show you both ways because I'm not going to make you pick. You're going to pick the way that makes more sense to you. Now, a geometric sequence has an initial value of 1024, and each term in the sequence is half of the previous term. Find the 9th term in the sequence. So, I know that A1 and R are going to be important because what does A1 always tell me? Yes, friend? You sure can. What's A1 always tell me? The first term tells me where to start. What is the first term here? It doesn't say the words first term. It says initial value. So initial value is where you start. So what do you start with? 1024. All right. It doesn't say the words constant ratio, but it says each term in the sequence is half of the previous term. Now, when you say half, or when I said half, you immediately think, oh, divide by 2. But I can't divide, I'm multiplying. So dividing by 2 is the same as multiplying by what? 1/2 or 0.5. Either one is right. It does not matter to me which one you use. So that's the information that you must know in order to do this recursively or explicitly. Okay? I'm going to do this recursively first. That means if I want the 9th term, I go back to the 8th and I multiply by 1/2. Well, if I don't know 8, I got to go back and find 7 and 6, 5, 4, 3, 2, 1. So recursively is like continuing the pattern. I want 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay? A sub 9, that's what I want. Now, I'm going to draw a little line, squiggle right here. This is recursive. I'll do explicit there in a second. Where does the sequence start? What's the very first number? 1024. Okay? Now, I am not about to do this in my head. 1024 times 0.5. Now, I could have done times 1/2, but I'm just going to be totally honest with you. Typing 0.5 is a lot easier than doing the fraction. That's why I did 0.5. If I want the second term, I take that first term, times it by 1/2, and that gives me 512. Now, I ultimately want this one, but I got space on 8, 7, 6, 5, 4, 3. If I want the third term, I look at the previous term of 512, and I times that by 1/2, and I get 256. What do I do to just keep going? Keep doing it. Keep timesing by 1/2. Keep timesing by 1/2. How am I going to know when to stop? Well, that's why I drew the blanks. I draw as many blanks as I need so that when I fill up all my blanks, that's when I know to stop. What is a sub 9, the ninth term? 4. That's recursive. That wasn't hard. Now, it takes a little bit of time, especially if I asked you for like a big number. But I didn't. I asked you for the ninth term. So I draw out however many blanks I need. I start with the first one and I keep the pattern going. So there are other students that would rather go straight to the answer. What number, what term do I want to know? I want to know number 9. Do I care about any other term? Nope. I want to know a sub 9. Now, I'm going to do this explicitly. Explicitly go straight to the point. A sub 9, so 9 actually is what n equals. So now I know n equals 9. Do you know A1? What'd you start with? 1024 times R, which is 0.5, to the n. What's your n? What number do you want? 9 minus 1.
So the A sub thing is just like the number you're trying to find.
That's telling you what number you're trying to find. That's exactly. It's a notation way of, instead of you saying, I don't know which number this is, you say, I know with 100% confidence this is the ninth term. So you know what I'm going to do? I'm going to take this. 1024 times 0.5, raise it up to the 9 minus 1. Bam, I got my answer. A sub 9 equals 4. That's explicit. Explicit is straight and to the point. It took me right to the number. I don't care about any other number there is. I just need 9. It is totally up to you which one you'd rather use. Both of them get you to the right answer. Number 5 says, a geometric sequence is defined recursively by a sub n equals negative 1/3 times a sub n minus 1 with an a1 of 729. Write the explicit formula to represent the sequence. So, I gave you one rule. I gave you recursive. I need you to turn it into explicit. So, let me look at my explicit rule right here. Okay? There's my explicit rule. What 2 things am I going to need to write the explicit rule? I'm going to need A1 and I'm going to need R. Well, what does this tell you A1 is? 729. In the recursive sequence, the number that you're multiplying by, so that's your previous term, that's your R. What you multiplying by over here?
Negative 1/3.
That is your R. So now that you know those 2 things, what you going to do with those 2 things? You're just going to replace it. So now, you don't have to erase and replace. I'm going to write the formula down first. You don't have to write the formula down. Imagine that you're looking at the formula. A1, I'm going to put a parentheses. So that would be R to the n minus 1. There's the formula. You used to not know A1, but I'm going to replace it because what do I now know A1 equals? 729. I used to not know R, but what do I know R equals now? Negative 1/3. I still don't know n because I'm making a formula or a rule that I could use to find any n you asked me for. If you understand what a recursive rule is telling you, you can take that information and make it explicit, and vice versa. I can give you an explicit formula, and you can turn it recursive. All right, number 6 says, the formula, now, I goofed up right there. That should be a subscript n, okay? I just forgot to subscript it when I was typing. Equals negative 25 times 2 to the n minus 1 describes a geometric sequence. Now, did I gave you a geometric sequence, but did I give you recursive or explicit? Explicit. You know one way you can tell? It's got 2 numbers. Explicit's going to have 2 numbers, and the exponent's going to have n minus 1. Recursive is going to have 1 number, and that a sub n minus 1. Now I need you to create a recursive function rule to describe this sequence. So, I'm going to be not lazy, and I'm going to find my formula sheet. And I'm going to look at my formula sheet, and I'm going to find out that, oh yeah, That's it. I really need to know two things. One of these numbers is A and the other is R. Look at your explicit. The R is the one with the exponent because that tells you that you're going to multiply this R over and over and over. Which of those numbers has your exponent? 2. That's your base. That's your R. Can y'all let my friend in? That makes the A negative 25. You've got to understand what explicit is telling you in order to write recursive. So here's recursive. A sub n equals R, which is 2, to the A n minus 1. That's your recursive rule. That is the right answer. Now, word of warning. If I gave you a multiple choice test, you know what answer choice I'm going to have on there? I'm going to put this. A sub n equals negative 25 times A sub n minus 1. That's wrong. But I used the right number. But what number is that really?
Because you have to put the ratio.
You have to put the ratio. That is actually where you're starting. You know what this is telling you? That you take every sequence and what do you multiply it by?
25.
Negative 25. That's not what this told you. This told you start with negative 25 and you multiply it by 2. You're going to have to be really careful when you look at any multiple choice answer choices and make sure. That's why I tell you, you need scratch paper. I know the test is on the computer, but that doesn't mean that the math happens in your brain. You take your scratch paper, you write it down, you solve the problem, and then start looking at the computer to see where your answer is on the answer choice. All right. Number 7. What is the 8th term of the geometric sequence 2, 4, 8, 16? Now, I want the 8th term. Short of cheating, I don't want you to cheat, of course. I want you to tell me the 8th term. I'm looking for a one-number answer. I don't care if you do it explicitly or recursively.
256.
Okay? Let's see. My friend thinks it's 256. Now, I'm going to do it both ways because some of you are going to like recursive, and that's fine. Some of you are going to prefer explicit, and that's fine. I'm going to start with recursive. But before I can start it, I need to know two things. I need to know A1 and I need to know R. A1 is where I start. Where do I start? I start at 2. Now, what are you doing to go 2, 4, 8, 16?
Well, times by 2.
You're timesing by 2. If you weren't sure, pick the last number, divide by its previous, and 16 divided by 8 is also 2. So, you need the 8th term. You need 1, 2, 3, 4, 5, 6, 7, 8 blanks. When you fill in that 8th blank, you're done. You got the right answer. Now, you already got part of it. You have 2, 4, 8, 16. According to what you told me, you're multiplying by 2 each time. So, 16 times 2 gives you 32, and 32 times 2 takes you to 64, and 64 times 2 is 128, and 128 times 2 is 256. Do I need to keep going? Why not? That's the 8th term. That's my answer. That took me what? About 30 seconds, and I got the right answer. It is fine if you do it recursively. I don't mind doing this 8 times. I don't even mind doing this 10. But if somebody asks me for the 30th term, I'm just not going to do it. I'm not going to sit there and multiply and write it down over and over. I'm going to do it explicitly. I told you, you know, I got a small attention span. I like to get done and go do something else. So this is recursive, totally works. You don't have to do this both ways. I'm showing you both ways because there are some of you in here that thought to yourself, ain't no way I'd do this. And that's fine. Let me look at my explicit formula real quick. Explicitly, I want the 8th term, so I'm looking for A sub 8. A1, I know is 2. My R is 2. Do you happen to know your N now? What number term do you want? 8 minus 1. Now, you're working this, and when you get stuck, I want you to think, what would Miss Slusher do now? There's a whole bunch of numbers. What would Miss Slusher do with all them numbers? Plug in them calculator. 2 times 2, raise it up to the 8 minus 1. And I also got 256. So my friend that did this recursively got 256. I did it explicitly and got 256. Who's right? Both of them. It just, you have to do what your brain understands best. All right, number 8 says, what is the 10th term in the geometric sequence 4 over 9, 4 over 3, 4 dot dot dot? Hey, what's that dot 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 mean? It continues. It keeps going, but I got tired of writing. Now, no matter which way I do, I know A1 is right there. Whether I do it recursively or explicitly, I have to know what R is. So in order to find R, I'm going to pick a number, pick a term, I should say, that's what it's called, and divide by the previous. You can technically pick whichever term you want. I encourage you, especially if you struggle a little bit with this, to pick the last one. The last one is 4, so what's the only thing that came previously before it? 4/3. Now, when you go to type this in, you got to be careful. You have a big fraction right here. What's the numerator, the top of your fraction? It's 4. The denominator happens to be a fraction under a fraction. And when you hit that, you find out that you're actually multiplying by 3 every time. So your R is 3. You're multiplying by 3 over and over. And just for the sake of me knowing, because I'm going to need it in a minute, what is my A1? 4 over 9. So if you were working on this and your mom or daddy comes in and you're working on your assignment, let's say you don't finish in class, and they say, how did you know that 4 over 9 is A1? How'd you know? It's the very first term. That's what it's called. A1's the first term. All right. I'm going to do it explicitly first, just to prove I can. So if I'm going to do this explicitly, I need this explicit formula right here. Okay? I want the 10th term. So I'm looking for A sub 10. A sub 10, which has now become N, equals A1. What was my A1? 4 over 9. Times R, which is 3, to the N, which is now 10 minus 1. What would Miss Slusher do with all those numbers? We'll type them in the calculator. I ain't going to think too hard about it. I'm just going to go 4 over 9 times 3 to the 10 minus 1. And I'm going to hit enter, and I'm going to get, wow, 8748. You got? Okay, good. I got scared. I get scared sometimes when I get big numbers, but then I have to think. I'm constantly multiplying a number by 3, and if the number gets bigger, and I multiply that by 3, it's going to get even bigger. And if that's a big number, and I multiply it by 3, it's going to get bigger and bigger and bigger. Now, that's explicit. That's all the work you got to have. So when you go in the hallway today, and you're doing some practice or on your assignment, I should see this work. Now, I'm going to draw a little squiggle, because I'm also going to do it recursive for those of you that rather have recursive. All right? Now, if you're doing it recursively, what term do you want? Which number? You want the 10. So how many blanks do we need to write? 10. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my 10th. You want me to tell you why I label that one? So I don't do it to me. And you just keep the pattern going. So you got 4 over 9, you have 4 over 3, and you have 4. That was your original pattern. If you want this term, you go to the previous, and what did you tell me you're going to do with it? Multiply it by 3. So 4 times 3 becomes 12. And what you going to do with this one? Multiply it by 3. Multiply that by 3, and I'm going to keep going. That's why I drew 10 blanks. I can just keep going until I fill them all in. Multiplying by 3, multiply by 3, multiply by 3, 8, 7, 4, 8. That is the 10th blank. I did it explicitly. I did it recursively. Got the same answer. It does not matter which way you work it. You pick what you understand best. And that's the one I want you to do. All right, last one says, The first term of a geometric sequence is -4, and the common ratio is 5. What is the sixth term? I want you real quick to find me the sixth term. I don't care which way you do. I don't care if you do it recursively. I don't care if you do it explicitly. I just don't want you to cheat and steal somebody else's number. So you find the sixth term. All right, so number 9, you worked it out. You can work this either way, but you need to get it straight in your mind. What is your A1? What is your first term? And what is your ratio? Your common ratio or constant ratio? What is your very first term? -4 and your constant ratio of 5. Now, your answer is -12,500. You can do this recursively or explicitly. Explicitly, I want my sixth term. So I say A sub 6 equals, let me find that explicit formula so I don't have to think so hard. Give me my paper. All right, A1 is -4 times R is 5 to the 6 minus 1. So when I take that and type that in, I get -12500. That's why Miss Slusher likes explicit. I just do that one thing, I type it in, and I've got it. Now, you may have preferred to do this explicit or recursively. I keep saying it backwards. You need 6 blanks. 1, 2, 3, 4, 5, 6. When you get this sixth term, that's your answer. Your first term was -4. You're going to times that by 5. So, -4 times 5 gave me -20. I'm going to continue this pattern of multiplying by 5 to get -100, times by -100 to keep going. I'm not -100, times by +5. I'm going to times by 5, and I'm going to times by 5 again, -12500. That's my sixth blank. Okay? So, what you need to remember is, do not be lazy. Do not let your pride get in the way of you looking up these formulas and using whichever one you want.